Hi guys, and welcome back. So we're again just gonna kind of be rolling along with this whole online learning business. So that means we're starting a brand new chapter. I have a very good feeling it is going to be a whole lot easier than the last one. I didn't think the last one was too bad either. But yeah, this is chapter 11. The section that we're going to talk about today, before you guys ask, is section 11.1. And chapter 11 as a whole is on perimeter and area. Yeah, there are going to be some like slightly more complex things that I don't know if you guys have ever seen before. But 11.1 specifically, which we're talking about today, is, as you can see, on perimeter and area of parallelograms and triangles. So I really don't think there's going to be that much today specifically that is unfamiliar to you. So that means I don't think it's going to be very difficult. I don't think chapter 11 as a whole is going to be too difficult. But again, I am a math teacher. I have been doing this for a really long time. So take my opinion with a grain of salt. There really isn't much, just as a heads up, about perimeter and like different perimeter formulas for the different types of shapes that we're going to be talking about throughout chapter 11. But I'm sure you guys know that all perimeter means is just to find the distance around, the edge of the figure. So like the perimeter of a parallelogram or a triangle is pretty much the same because it's just the sum of all the sides. All right. So you're not going to see too much of that. All right. The point of this slide is the fact that depending on how your parallelogram is oriented, any side can be the base, all right? Typically, when we talk about the base, as you can see from this picture down here, it's the flat portion that kind of looks like it's like resting on the ground, What matters, though, is the height, all right? Because as we sort of talked about when we were talking about altitudes of triangles in the last chapter, the height has to be perpendicular to the base. All right. No matter what you're considering your base, your height has to be perpendicular to it. So depending on how your parallelogram is oriented, your base might be different, which means your height is going to be different. All right. So I think we've talked about the area addition postulate before, maybe. I know we've talked about the segment addition postulate, the angle addition postulate, and so the area addition postulate is very similar. If you have two figures, the area of a region that is constructed of two figures, it's the sum of the areas of both of those individual figures. We're actually going to talk more about this in a later section. I believe it's section 11.4. I'm honestly not 100% sure. I know some of you guys, if you really do want to look a little bit ahead, the area addition postulate shows up in whatever section talks about composite figures. We are going to talk about it at some point. I don't know exactly when, but yeah. Area of a parallelogram, though, is more what we're focusing on today. I'm sure you guys know the formula for the area of a rectangle, formula for the area of a square, base times height. Well, guess what? The formula for the area of a parallelogram, as you can see, is exactly the same. All right? Again, you just got to be careful with your height. Like the slanted part is not the height, all right? It's this perpendicular part. So that dotted pink line, H, all right? That's the height when we're talking. That's the height that we're talking about. So, of course, though, I wouldn't make it that simple for example 1. So perimeter, I think, is a lot easier. It's just, again, the sum of all four sides, all right? But what I hope you guys didn't forget specifically about parallelograms is that opposite sides are congruent in a parallelogram. That's what's going to help us with the perimeter. So that means if DE is 17 meters, so is FG. If EF is 27 meters, so is DG, 27. And then there's enough information that we need for the perimeter. 17 plus 17 plus 27 plus 27 is something. 88. So the perimeter is 88 meters. You are probably going to have a check on this at some point. I know somebody was asking in the Google Hangouts about like, oh, we can't have quizzes anymore. you're still going to have checks. They're just not going to count as a quiz grade. And the whole point of me saying this is the fact that because we're talking about perimeter and area, I will be looking for units. All right. So I will be looking that you have that 88 meters instead of just 88. All right. And when we talk about area in a minute, I will be looking for meters squared. Okay. Area. All right. I put this 27 here just to show you that it's the entirety of DG instead of from G to the pink part, because that's going to be our entire base. All right. So the area is going to be 27 times this pink height. How are we going to find that pink height though? Well, that's part of the reason why the right angle symbol is there. If this side is a right angle, this side is also a right angle. So like if I call this part H, DHE is a right triangle, which means you can use Pythagorean theorem to find EH. Or you can also use triples if you still remember your triples. It is a triple. It's an 8, 15, 17 triple. So that means the height is 15. So the area then is 27 times 15, which is 405. So this is 405 meters squared. Excuse me. That's it. All right. Same idea. The 12 is talking about the entirety of SR. So again, opposite sides are congruent. PQ is 12. SP is 9. So the perimeter is all 4 added up, which I'm lazy, so I'm just going to do this in my calculator. 18 plus 24 is 42. That's the perimeter. All right. And I really wanted to put the 9 there because this is going to help us find this height. All right. Again, it is a right triangle, but that 45-degree angle says or tells us a little something different. That now it's not just a right triangle, but it's a 45, 45, 90, which means you can use your 45, 45, 90 rules. If P, again, we'll call this like T or something. PT is one of our legs. SP is our hypotenuse. And the hypotenuse is your leg times root 2. So if our leg is H times root 2 is equal to 9. So that means H is 9 over root 2. We don't want radicals in the denominator, so we have to rationalize. A nicer way of this looking is 9 root 2 over 2. We've done this before. All right. So that means the area is still base times height. So it's 12 times 9 root 2 over 2. 12 times 9 is 108 divided by 2 is 54. So the area is 54 root 2 meters squared. And you could absolutely do 12 divided by 2 is 6 times 9 is 54. I won't be picky about that specific order. But yeah, that's fine too. Okay. Now, of course, if we were dealing with 45, 45, 90 triangles, we could absolutely deal with 30, 60, 90 triangles as well. Perimeter, easy peasy. 12, 8. So that means it's 16 plus 24, which is 40. So our perimeter is 40 units because we don't have units. So it's this blue that we want. All right. So this is a 30, 60, 90 triangle. So everything though is in terms of your short side. So if the 30-degree angle is up here, this part down here is your short side. All right. So your short side in regards to your hypotenuse is double your short side. So that means your short side is going to be 4. And your height is going to be, or your opposite the 60-degree angle, your long leg is going to be your short leg times root 3. So your height is 4 root 3. All right. Don't forget your 30, 60, 90 rules. So that means when we do area, it's going to be 12 times 4 root 3, which is just 48 root 3 units squared. There you go. The area congruence postulate is the most self-explanatory thing ever. If two figures are congruent, then they have the same area. Obviously, if two figures are congruent, that means they have the exact same measurements, which means side lengths and all that stuff. So if they have the exact same side lengths, then of course they're going to have the exact same area. All right. And again, well, not again, but the area of a triangle, you've seen this before. I really don't think the formula for the area of a triangle should be news to anybody. All right. There's two ways you might have seen it: half times base times height, or base times height divided by 2. Whichever way you're comfortable with using it is whichever way you're comfortable with using it. I don't really care about that. I usually use the 1/2 base times height because that's the way I was taught it when I was in middle school. But again, doesn't really matter. They mean the exact same thing. So with again, with right triangles, if we're finding the perimeter, you need all three sides. So since this is a right triangle, we are going to have to do Pythagorean theorem again, or maybe it's a triple, If we try to break it down to see if it is a triple or not, we're going to have to divide 20 and 12 by some kind of GCF, if you guys kind of remember doing that. 20 and 12 are both divisible by 4, so that'll get you 5 and 3. And so it is a 3, 4, 5 triple, or a multiple of the 3, 4, 5 triple. So this side would be a multiple of 4. But what multiple? Well, if we divided the other two side measurements by 4, we're going to have to multiply them back out by 4. So the length of B is actually 16, which means the perimeter is 12 plus 16 plus 20, which is 48. So 48 meters. All right. And again, when we talk about base versus height, base we usually refer to as like the bottom part that rests on the ground. And then the height always has to be perpendicular to that horizontal base. So in this case, our base is 16 and our height is 12. So the area is going to be 1/2 of 16 times 12, which is 8 times 12, which is 96. So 96 meters squared. And there you go. All right. Now, when we talk about, perimeter, all right, the nice thing is that we have some right triangles here. So we can still do Pythagorean theorem. You got to be careful, though, for 2 reasons. 1, we're going to need both of these sides in order to figure out the perimeter. And 2, even though this is 15 and 17, when we talk about the 8, 15, 17 triple, as I'm sure you guys remember, the hypotenuse always has to be the longest side of the triangle. So that means in an 8, 15, 17 right triangle, the hypotenuse would be 17 units. That's not what we have here. 17 is a leg. All right, so we're just going to have to do Pythagorean theorem the old-fashioned way to get this length. So 15 squared plus 17 squared is c squared. So that's 225 plus 289, which is 514. And the square root of 514 is a gross decimal. So I'm just going to try to simplify the radical real quick. How would the square root of 514 simplify? Can it simplify is the question. Don't mind me, I'm just trying to simplify that radical. I don't think this can simplify. Yeah, I don't think the square root of 514 can simplify, so it looks like that side is just the square root of 514. And we'll deal with that later. Okay. So, in regards to this final side, All right. It doesn't look like the shaded gray is a right triangle, which is not. But what you can use is the fact that this vertical 17 and the 15 plus the 25 forms a giant right triangle with the whole thing. You know? So this is going to be the hypotenuse of our whole big right triangle. So I think we're going to have to do the Pythagorean theorem all over again. 17 squared plus 15 plus 25 squared. So that's 40 squared. So 289 plus 1600. So that's 1889. Ugh. Okay. I'm actually going to pause this for a second so I don't waste your time and try to simplify the square root of 1889 off camera, as some of the YouTubers say. All right, so I just tried to simplify the square root of 1889, and I couldn't do it. So it looks like this is going to be another very ugly radical. But that actually sort of makes our lives somewhat easier, because if they're all kind of gross radicals and one is just a whole number, there's nothing that you could really do with it, unfortunately. So the perimeter is just going to be 25 plus root 514 plus root 1889 centimeters. All right. That's it. I feel like these numbers are too gross, but if you think I messed up somewhere, you have every right to call me out on it. Let me know. Area, though, is different, because if you look at the actual triangle itself, this 15 right here is a little bit extra. All right. It's not actually part of the base of the triangle. The base of the actual triangle is just this 25. All right. And then the height has to be perpendicular to the base, so the only vertical portion of that is 17. So our base is 25, our height is 17. So that means the area is 1/2 of 25 times 17, which might be another decimal. Yeah, it is another decimal. It is 425 over 2, which is 212.5 centimeters squared. Okay. Well, you know, it's level 1. You're going to have to deal with some pretty gross numbers at some point. So there you go. Okay. 2B is honestly really similar. All right. What we're talking about is the shaded triangle in gray. All right. Again, this is another one of those where if you talk about that multiple of the triple that we did earlier, the 12, 16, 20, 20 would have to be our hypotenuse, which it's not. So this would be our hypotenuse, so we're going to have to do Pythagorean theorem again. Luckily, we only have to do it once because this is the third side of the triangle. So 12 squared plus 20 squared is c squared. 144 plus 400 is 544. And that's not a perfect square, so again, I'm going to pause, come back, try to simplify it. All right, so the nice thing about the square root of 544 is that it did actually simplify this time, okay? It simplified into the square root of 16 and the square root of 34, okay? So our hypotenuse is 4 root 34, which means the perimeter is 12 plus 20, which is 34, plus 4 root 34. Again, can't combine that because one has a radical, one doesn't. Inches. Okay? You got to be careful, though, because, you know, the thing with this is the fact that, again, we're only talking about the area of the shaded triangle. So that 16 on the outside, I think, is actually extraneous information. You don't really need to worry about it. All right? Area, then we're talking about base and height. So base is your flat horizontal. Height is your perpendicular vertical. So the area is just going to be 1/2 times 12 times 20, which is 120 inches squared. Again, if you think I'm giving you the wrong information about something, absolutely call me out on it. But what else is there? Okay, a couple more. The height of a triangle is 12 inches more than its base. The area of the triangle is 560 square inches. Find the base and the height. All right, so we already know the formula for the area of a triangle. It's half base times height, okay? But we're talking about the height in terms of the base, all right? So if we have the base, the height is 12 inches more than the base. So the height is whatever the base is plus 12. And it's those two things that we're going to use to sort of write our own little formula. You know, we know the area is 560. So 560 is equal to 1/2 times the base times this expression that we know for the height. Base plus 12. Okay. Well, the first thing I'm definitely going to want to do is get rid of that 1/2 because that's going to make our lives a whole lot easier. So you can either divide by 1/2 or multiply both sides by 2 to get rid of it. 2 times 560 is 1120. That equals the base times the base plus 12. And I wonder if you guys know where this is going, because I already know where this is going. We're going to have to distribute the b. So 1120 is b squared plus 12b, and yep, this is something that we're going to have to factor. I told you it wasn't going to be that easy. Now again, I'm actually not 100% sure what the factors of 1120 are, so again, I'm going to pause, and I'm going to come back. All right, so it took a while, but we got there. Factors of negative 1120 that add up to 12 are 40 and 28. Okay? So, because it's positive 12, we want b plus 40 and b minus 28. So that means our base could be either negative 40 or 28. But, again, you have to remember, this is geometry, you know? If you're talking about a base has a length of negative 40, that makes no sense. Length can't be negative. So the only possibility for our base here is 28. Which means our height is 40? Yeah. Do we have units? Inches, inches. There you go. All right. You guys know by now there are plenty of places for you guys to reach out with questions, Hangouts, the question forum. There's still signups going on for video calls, all that stuff. But just one more, very similar, almost identical, just some different numbers, so you really kind of get the hang of what's going on. The height of a triangle is 7 inches more than its base. So again, here's our area formula. And if we have a base, the height, we know, is 7 inches more. So it's b plus 7. All right? So our area is 60. So 60 equals half times the base plus 7. And I'm going to do a couple things at once, like we, just for the sake of time, because we're over 20 minutes now. I'm going to clear the half, so this is 120, and I'm also going to distribute the b in. So this is b squared plus 7b. So b squared plus 7b minus 120. And again, I'll be back when I figure this out. All right, so that wasn't as bad, obviously, because 120 is a much smaller number. Factors of 120 that add up to 7 are 15 and 8. Or negative, 15 and negative 8. Yeah, because we want positive 7. So b plus 15 and b minus 8. So again, b equals negative 15 and positive 8. We don't want a negative side length, so the only possibility here is 8 inches, and that means our height is 15 inches. So it doesn't look like it's actually that bad, because when you find the factors of 120, that kind of helps you figure out what the actual dimensions are. You know what I mean? Like we had 8 and 15 here. We had 28 and 40, we had 28 and 40 here. All right, I don't know if that's going to work every single time. I just figured I'd point that out because I noticed it. Maybe that'll help you guys out as you're doing these problems. All right, so slightly more difficult than I think all of us had anticipated. But again, this is a level 1 course. I really don't think it's anything out of your wheelhouse. We've done 45, 45, and 30, 60, 90 triangles before. We've done radicals. We've done Pythagorean theorem, simplifying square roots, factoring. We've done it all. It's been a while. All right. So I don't want you to lose those skills. Just maybe brush up on them if you think you need them. All right. But that's all I got for you today. Stay safe. I'll talk to you soon.